So in this video, we're going to see how to interface a switch to a Raspberry Pi. Uh, um, Now you can see the diagram we're going to be working with here. We have a switch here. We have a 10 kilo ohm resistor here that is being pulled up to a 3.3 volt point here. Then we have the other end of the switch that goes to our ground. Then the other end of the switch goes to pin 25. That's GPIO 25 here. Okay, then we have our LED connected to GPIO 14. So the target is when you click on this button, when you press the switch here, you realize the LED comes on instantly. So when you press the switch, the LED comes on. You press the switch, the LED comes on. Very, very easy to do. So let's give it a try. Let's see how to build or develop such system. So we're going to, first of all, I would like to let you know that you must not use a pull-up resistor. For the GPIO pin here, you can actually activate the internal pull-up resistor connected to it using your program or using software. This is similar to what we have, but by the time you you remove the external resistor and activate the internal pull-up resistor, you are going to have something like this, like you can see right now. No resistor used anymore. The resistor used here is actually internally. So let's see how we can develop such a system. Let's see how we can do that. So the first thing we're going to do is let's write a program that we are going to be working with. So I'm going to minimize this, then bring back my Raspberry. So we're going to we copy this. So we'll create a new script. So this new script, all we're going to do is so I'm going to just delete what we've done here before and use the setup. So we'll import like before our RPI.GPIO and also import time, then set mode to BCM, then set one is false. Now the setup here, the first one is going to be our LED, which is 14. We don't need 23, we're using 25. Then the next thing here is for the 25 point where our switch is connected to, we need to set it up as an input, not output. So it's going to be GPIO.in. Now, one other parameter that we can pass is called pull up. It's called pull up underscore down. So in pull up down, we are going to say GPIO dot PUD underscore up. So this is what we will be using. Now, so what this line does here is that you are activating the internal pull-up at GPIO 25. We activated the internal pull-up at GPIO 25. Okay, so we are done with that setup. So the next thing, let's close this gap. So the next thing we are going to do is to quickly start the project. The logic. So what do we want? First of all, I'm going to ensure that the LED is off at startup. That means I'm going to say GPIO.output. I'll make sure 14, is set on low. That's GPIO.low. Another way is you can just make it false. Another person can use 0, it stays the same. Or you can just say instead of stressing yourself. You just type in false here, and that's it. It does the same thing as putting a low here. So you either use false, 0, or a low. So because we want our system to continue to work non-stop, we're going to set a while loop always true here. So we're going to create a variable, we'll call it button state, that will be used to pick the state of our button, of our switch being pressed. So I'm going to say GPIO dot input. So in GPIO dot input, I'm going to pass in the pin where we are expecting an input, and that's 25. So after passing it there, I'm going to say if our button state, button underscore state is equal to, if it's equal to false, then false means if it's equal to 0, then GPIO dot output, that's our LED this time around, connected at 14. We're going to on it by just saying true, right? So the next thing is we need to prevent what I call the bouncing when you're pressing the key or the switch. So to prevent the bouncing, we're going to introduce a while loop that will capture the current state and hold on to it until your hand is out of the switch. So that's pin 14. So we are saying that if it's equal to false, why this is equal to false, let what happens, probably we might just introduce a slip here. So we might just introduce a slip here, time.slip. So what are we, how long? Probably just 0.2 seconds is fine. Yes. So the next thing is we have an if condition here. So we have an else. Else means in the case where the button is not false, what do we want? That means the LED should go off. So simple, the LED should go off. So I'm going to do GPIO dot output. So our LED is at 14, so I'm going to make it that's false. So false makes it go off, while true makes it come on. So let's test this program to make sure there's no error. I'm going to just run it this way. So no error, as you can see, we don't have any error here. So I'm going to just stop it. Run it again. Okay, it didn't run before, so we are prompted to save. So I'm going to save this. I'll call it switch.py. Okay, so it's running now. There's no error, so I'm going to stop it. So let's get our hardware connection right before we run this program to run a test. So our hardware is going to be easy to do. We have a switch, as you can see. So this is a button switch. We have wires that we're going to be using. Then we have a red LED. Then we have a resistor. So this is just what we need for this project. So first of all, let me connect our LED. Don't forget our GPIO pinouts. Don't forget our pinouts that we're working with here. So one end of our wire goes to negative. Negative is the third point here. 1, 2, 3. While the other end. So These are negative, it goes to our resistor. At that end, it goes to our LED. So we are done connecting our LED. The next thing is to connect our switch. To connect the switch, we only need these two ends here. So I'm going to just use any point here, then link our wire directly from counting 1, 2, 3, 4, 5, 6, 7, 8. So at the 8th point. So 1, 2, 3, 4, 5, 6, 7, 8. Okay. So these 2 points will be going to the switch. Doesn't have a polarity. The switch doesn't have a polarity. So you can interchange the wires, no problem. So we are fine. Let's run the script and see if it works. So I'm going to click on run. So right now it's running. If I press my switch, so it doesn't work. So we need to check our connection. 1, 2, 3, 4, 5, 6, 7, 8. Oh, we are using the wrong point. This is 23. This is 23, GPIO 23. So our 8 point is 23. Okay. Our 8 point is 23. So we need to count 8, 9, 10, 11. 11. So 10 and 11 are what we need. 10 and 11. So I'm going to disconnect this. This is 8, 9, 10, and 11. You must ensure that you are using the right GPIO pin. You can see, so it's working accurately. We're using GPIO 25. Right now I press my switch, I hold it, it remains on, I remove my hand, it goes off, I hold it. So as easy as that. So using a switch on Raspberry Pi is not difficult. It's very, very simple. Very, very simple. In less than 20 lines of code, you can write a code that interacts with your switches. So I believe this is clear. I believe this is simple. We meet in the next lesson where we continue. Thank you.